So, my name is Leonid Igolnik. I am with Oracle today. I've been with the company about a year and a half. I've joined an Oracle through an acquisition. We'll talk a bit more about that later. We're going to talk a bit about performance tuning, some of the things you can do specifically with tools that most of you probably have on your machines. And most of the tools, actually, every single tool I'm going to show today costs exactly $0. It's cherished the moment because it's not that often you see somebody from Oracle who will talk to you about something we're willing to give to you for free. We're not in that kind of business. But today we're going to talk about free tools. Before we get into that, I should really start my timer. I do work for a large company, and I have to say that anything I'm going to be talking about here today are my and only my opinions, and they do not represent the opinions of my employer. What's that? So I'll do a brief introduction. We'll talk a bit about what I do and how I came to know what I know and as much as I know about performance tuning. We'll talk about a bit about you so we can tailor the talk. We'll talk about high-level theoretical concepts of performance tuning and what performance tuning is all about and how can you go about it successfully on a very large code base, millions and millions of lines of code, quite often a code base that you haven't seen until the day you were asked to look at the performance problem. We'll do a bunch of live demos and debugging. And I'll talk about some further reading and some other talks to consider if you guys want to learn more about that. There are several very, very good talks that are on the market. There's a great book on that subject. So, in spite of having grown up in St. Petersburg, I spent most of my professional career in English-speaking countries, so I will do this in English. I may tell a story or two in Russian. We'll see how this works. And I started my career at a company called, well, not started, but worked for a while at Tukas. A lot of people don't know that Tukas for a while was a second largest domain registrar in the world. We were pushing billions of transactions through the system. We were also the first company that got the .info, .biz, .org domain registry. So Martin over there, myself, and a few other folks were involved with that. OpenSRS was the brand, and that's where I got to start working on Java. So I've been doing Java about 12, 13 years now, I think. My last big employment was a company called Teleo. Prior to the acquisition by Oracle, Teleo was one of the 4 largest independent software as a service companies in the world. We built HR, human resources applications. In 2012, the company got acquired by Oracle. The year before, in 2011, we have helped our customers process, I think, something like 50 or 60 million applications for job, actually more than that, and 15% of anybody who got hired in 2011 in the United States came through our systems. So a fairly sizable system that we have to deal with things like performance tuning and scalability. In the next 60 minutes that this talk is gonna last, we will process about 5 million transactions or about 1,400 transactions a second. That's the typical volumes that we deal with. We will help our customers post about 600 jobs, net new jobs that they're looking to fill. About 24,000 applications will get submitted during this hour, and about 580 people will get a job offer through our system. So roughly the same amount of people that are at the conference today will get hired. So, now that you heard a bit about me, let's talk a bit about you guys. So, let's do this by a raise of hand. Who here builds products that are built in Java? Okay, not surprising, it is a Java conference. Baruch, you too? I thought you switched to Groovy. Who here builds products that are not built in Java? Okay. Well, the good news for you guys is, while the tools that I'm going to be showing today are not the same tools you would want to use, but the techniques are roughly the same. Who here builds actually, not really in Java, but in languages that still run on the JVM? Scala, Ruby, JRuby. Okay, good news, both the tools and the techniques apply. We'll skip this, business, web. Anybody here, we'll do it in reverse. Anybody here has built applications that don't have to scale or run fast? Yeah, I thought so. Otherwise, you probably wouldn't be here. So, let's see. Applications that I build, and keep your hand up if it's more than 100 users a day. Now raise your hand and keep it up if it's more than 100 users a day. More than 1,000 users a day. Keep your hand up. More than 10,000 users a day. Okay. More than 100,000 users a day. Okay. More than 1 million. 1, 2, 3, 4, 5. You don't count. And I just don't know. Anybody who just didn't raise their hand because they didn't know? All right, 1, 2. Okay, got it. So, performance tuning. Why is it important? It means money. In the business world, most of our applications that we build today have to scale, because if they don't, it can cost us a lot of money. Here's a recent example I like. NASDAQ was fined about $10 million because they botched Facebook IPO. And the reason they botched Facebook IPO, the demand for the stock was so high that it pretty much overwhelmed every single trading system and every single ounce of capacity NASDAQ had. So this stuff in a lot of our applications can cost the company a lot of money. A lot of us have to deal with things like SLA, service levels agreements, right? Where a customer will say, hey, your application will respond in less than half a second on average and no more than X seconds if you're running a report, right? That means a lot of money in a lot of cases. Our product service both small customers and Fortune 100, some of the largest corporations in the world, and they have their demands because they do pay us a lot of money. So, what is this? What is performance tuning, right? When I look for a definition, I go to the source of all truths in the universe, also known as Wikipedia. And this is the quote that you'll see in Wikipedia, right? Performance tuning is the improvement of the system performance. Motivation for site activity is a performance problem. So typically you have a problem that you're trying to solve. The problem can be real or anticipated. And that's actually extremely important to understand. Did anybody ever try to performance tune your application while you're still building it? How many of you have guessed correctly the actual performance bottleneck that happened when you rolled it out? One or two? Okay. Yeah, it's very, very difficult. We're building highly componentized, highly dynamic systems, and guessing and predicting the actual performance of the application becomes extremely difficult. So there are other ways of doing it. Now, I'm not advocating abandoning best practices, right? There are standard 101 best practices that you do want to ensure that you adhere to. Otherwise, you won't have anything to tune when you go to production. But tuning stuff ahead of time can be a tricky bit, right? So performance problem and performance tuning is extremely important because understanding what is that you're trying to fix is paramount. Otherwise, you may not be fixing the right thing. Real or anticipated? I think we talked a bit about that, right? My advice to you guys, don't try to guess where the bottlenecks are. We tried in our applications. We have highly componentized applications with pool of components that have to be sized and properly configured. We never know what's going to happen. Especially, and since most of us are lucky enough to work on systems that we have not built, your system looks like this. And I had to take over a number of systems in my career where, yeah, the system does look like this, but it is what it is. It powers a business. It's a fact of life. Bottlenecks come up. How do you deal with this, right? You're certainly not going to go through all those wires and figure out what connects to what, much like you shouldn't be going through the code and trying to read the code when you try to tune the application, right? Systemic way of doing this typically involves those 5 phases. And they're establishing the acceptable behavior. What is it we're optimizing for? Is it memory? Is it response time? Is it throughput, right? We need to be able to process 10,000 reports an hour. Understanding what is that the metric you're tuning for is the first step, right? Then you have to measure. In order to measure effectively, you need to have an arsenal of tools. And that's the biggest challenge, and we'll see some of the standard Java tools that we as Oracle ship and a bunch of other free available tools that allow you to measure the actual items that you're trying to tune. Right? So measuring the performance. I'll tell you guys a story. I have a friend in California, and that's where I'm based, who owns a construction company. And I was standing next to his work truck once, and I said, hey, Andre, I see in your work truck you have 5 different drills. How come? Well, he goes, well, you know, there is one for concrete, there's one for wood, there's this really light one. The battery life kind of sucks, but if I have to climb the roof, I'll take it on with me, right? There's a variety of different tools available, and knowing which tool excels in measuring what is extremely important, and build this arsenal of tools. We are all professionals, right? I have collected a variety of little, small, open source commercial tools over the years that I know that I can go to if I need a particular problem. And having the right tool for the job is extremely important. The other thing that is extremely important is also understanding your operating system. Whether you are on Solaris, Linux, Microsoft, my condolences. And there are people that deploy large-scale applications in Java on Microsoft. It's mind-boggling, but it is what it is. So absolutely having a unique and deep understanding of what your operating system does and offers is paramount for you to know what's going on. Also understanding your container, right? We all deploy into a variety of different containers with their unique characteristics, unique tuning tools, unique tuning techniques, as well as unique tuning monitors and capabilities. Learning more and understanding your container intimately is extremely important. I may come back. Actually, I'll talk about the Tomcat connector. The ModJK connector in Tomcat has a lovely feature called caching for static files. You can play with some parameters, the time of the cache, the size of the cache. If you don't know about that, you probably won't be able to solve a particular problem, especially if in your architecture you're serving static files through Tomcat. Not a good idea in general, but if you do, knowing how to tune that becomes extremely important. Also understanding your runtime environment. You know, one of the things I discovered when I joined Oracle is we have multiples of everything. We have 3 or 4 databases, 3 or 4 app servers. We have 2 different JVMs. Well, guess what? They don't behave the same, they don't tune the same, the garbage collection doesn't work the same. The good news is actually they're converging. So with Java 8, and that's not a promise, but the hotspot and JRocket will converge. I can make any promises, otherwise somebody from our legal team will come after me. But understanding the differences and measuring, and in times back in the day when Martin and I were working on the registry launch, we actually done performance testing on both JVM to decide which of those is appropriate for which workloads, because some of them handle different workloads differently. And of course, if you ever write on something on Microsoft.NET, as my friend says, may the God be with you, because we will not. JDK tools. Well, the funny thing about the JDK tools, there are a lot of them. Who has ever done LLS or dir, a directory listing in the Java home bin directory? Yeah. Those of you that haven't, please do. There's tons of useful stuff that we ship. And I'll tell you guys a story how one of those tools, JInfo, actually saved me because I was a young engineer carrying a pager on an escalation pass. And I got paged at 2 a.m. in the morning. It was Friday night to Saturday night. We've been drinking heavily the night before. And if I didn't know how to use that tool, I would be up troubleshooting the problem for 4 hours, not for 10 minutes. Basically, we found out that the wrong version of the JVM was running, but it wasn't quite obvious just by using the Unix tools. So check those tools. They have amazing documentation. They have man pages. They have very useful techniques. Unfortunately, this talk has 2 versions. This is a 90-minute version, and I show some of them today. We won't have that time, but I'll show you some. So JInfo, understanding Java runtime parameters, which VM is running, what are the libraries that are loaded, etc. Extremely useful in the production environment, especially if you're in a foreign production environments that you've never seen. JMap, just understanding what's going on in the heap. JStack for getting heap dumps, extremely convenient if you need to connect to a remote server. So, once you know your tools and you know how to measure what is that you're trying to tune, then your next logical step is trying to find the bottleneck, right? And identifying that bottleneck is extremely important. There's a gentleman who inspired me to write this talk when I wrote it for the first time, Kirk Peppendine, who is a big shot consultant. Kirk and his crew do a lot of performance consulting, and he coined this term called the dominating consumer, right? So, and that's what I'm going to show you today. How do you performance tune? By looking for your dominating consumer. A dominating consumer is something where the application is contended. It could be operating system CPU time, could be CPU time, could be memory throughput, could be I/O, right? So looking at a performance problem and finding your dominating consumer is how you start tuning your applications, especially if you want to do it blind. The other thing Kirk talks about is tuning your applications by not looking into the code, because it's a never-ending nightmare to try to find that needle in the haystack, and it is a needle in the haystack, right? You want a tool, and you want to have a tool, and you want to know how to use the tool that gives you what we call a vector into the code. Ideally, you have a tool that gives you a vector into a class, method, and a line of code, and some of them do better jobs than others. Some of them will just narrow it down to a particular method, and we'll see those. And I think with that, we're going to switch to a live demo. If the phones are too small at the back, please yell. And with that, I'm going to show you some stuff. So first, I'll show you one application that we ship with the JVM. And I hope you all have seen it or used it. Who here has used JVisual VM? OK, this may be a very boring talk for you then. I'm sorry. Maybe I'll show you 1 or 2 things. that you haven't seen before. So JVisual VM is a little visualization tool. I'm running locally, so it's easy for me to run it, but for those of you that have not seen it, JVisual VM can be easily connected to a remote server. Take some playing with networking, etc., but it's doable. So what you see in JVisual VM is all the apps that are running on a particular VM on the same machine. You can easily connect to it. You can inspect it. Much like JInfo, JVisual VM will give you some of this useful information. For example, what were the system properties in case you need to. Here's an example of a, not necessarily a performance tuning problem where this came in handy. We had an application that had to reach out of the data center on an HTTP endpoint, and it couldn't. Well, we found out that the proxy that was giving to the JVM was misconfigured, and the easiest way to find it out was to look at the proxy hosts that will pass in the command line, right? So you can look at the system properties, you can look at the JVM args. You can also monitor threads and the memory utilization. This app is sitting idle right now, but you can see what happens over time. You can force the GC, you can force performance of the heap dump, and again, all of those things can be done from a command line, but it's very convenient. You can look at the threads. You can do some sampling, profiling. There's some plugins. JVisual VM has a rich ecosystem of plugins. Some of them are on the plugin exchange. Some of them you have to download and install. Here's one called Visual GC. Kind of shows me what's going on with my garbage collection. I have my old gen, Eden, S0, S1. I can look at the JIT compile times, class loader stuff, right? Very interesting to observe the application as it runs. For example, this one seems to be increasing Eden space. I don't know why, because it's sitting idle, but back to that later. So very, very handy tool. There's another plugin called Tracer. You can install a variety of different traces. I won't have time to go into all of them, but something to play with. The other app that will come in handy that I'll show you today, and it's a very Mac-specific app, is we're going to be using this performance monitor application, and we'll get the CPU history app. So I'll explain how it works because it's very OS specific. Can you guys see this at the back? Yep, all right. So this is a quad-core machine, so there are 4 CPUs. The green stuff is the CPU spent in user space. The red, if you can see the red, is the CPU spent in the system space, right? That could be a dominating consumer. Your operating system may be taking disproportionate amount of time on your server. So, and then we have this application that, and by the way, it is a dummy application. The examples are designed for a quick demo, but they're very reflective of some of the real-life problems I have seen in production. And one other thing before we get into measuring in the real-life application, warm-up. As you can see, this application starts up and does some warm-up and says warm-up done. It's extremely important to measure and performance tune your applications after your application reached steady state. Typically, applications will start up, they will build up caches, the permgen will get the classes, right? Stuff will settle. You really don't want to measure or tune while the application is starting up. You need to figure out what is that steady state. When do you reach it so you can start measuring? In this particular example, I have this little warm-up that pre-warms the caches and does a bunch of this stuff. And then I hit enter and the app runs. And it prints a dot for every 100 or whatever thousand things that it does, and then it says, hey, it took me 6.1 seconds to do this, whatever is that I'm doing. And I just showed up. I don't know what it does, nor do I care. So imagine, if you will, your boss comes to you and say, hey, listen, Leonid, this app that we have, 6.1 seconds is unacceptable. We have the sales guys sold this to a customer and they told them it's going to be half a second, or maybe 0.8 seconds or below. Never happens, right? Sales never overpromises. And you go, okay, so what am I going to do? Now, this app is 15, 20 lines of code. We're certainly not going to read them, but we're going to start figuring out how to measure it, right? So let's see what we can do. Let's start with the very first thing. I want to look for the dominating consumer, and I'm going to start with the CPU, because CPU, memory, I/O are the kind of 3 key items. So let's run this, and watch the CPU on the right. So it will warm up. So the CPU graph jumps. We'll give it a second to settle so we can get, again, back to steady state. So I'm looking at the stats. I know I'm in steady state right now. And then I'm going to hit enter. And watch the CPU chart. What do you guys see? What's happening here? Come on, this is where you talk back. Anybody? Anything suspicious here? huge CPU activities, and yet, by the way, have you noticed we're not maxing out all 4 CPUs, right? I have this powerful machine, but about 3 of them are maxed out. Anything else stands out? Sorry? That's right, a lot of CPU activity in the kernel. That's kind of strange, right? Kernel CPU activity, context switching, expensive stuff. There are certain things that JVM does that cause it to go and do a context switch, especially in the multi-core environment. So we're going to try to find that. And to do that, I'm going to get JVisual VM. I'm going to connect to the app. And we're going to look for stuff. One of the things that causes a lot of memory activity is locking or synchronized blocks, right? Because you have to go to the OS, look at the mutex, make sure other threads on other CPUs don't have it. So here's the thread monitor. Green is running, yellow is wait, purple is sleeping, and red is monitor. So let's see what's going on. So let's start this and watch the threads. So what do we see? The app has started 10 threads. Well, the funny thing is a thread pool. Somebody read the book. Java concurrency is practiced here. But the funny thing is, out of all of those threads, only one of them is typically active at any given point of time. Suspicious. So, any ideas on how to figure out what's going on inside? Sorry? Synchronization, but how do we know where? Again, this is a multi-million line of code application. Most likely synchronization, but how do we find the spot? Any thoughts?
Thread dump.
You shut up. Thread dump. Awesome, I like that one. Let's try. Let's try a thread dump. There are 2 ways of getting, well, there's more than 2 ways of getting a thread dump. If you're on Windows, there are no way, again, may the God be with you, because the JVM is not. If you're running on Microsoft, good luck. We were trying to extract something from a virtual machine running on Microsoft that we got from a vendor. We brought our own JVM guys in. Like, fortunately, we work for Oracle, so we can call the JVM guys. We can figure out how to get the thread dump out sometimes. All right, so I'm going to connect. Again, JVisual VM has this thread monitor, and there's this conveniently located thread dump button. So I'm just going to press the thread dump button. Excellent. Get the thread dump. Here's the basic text thread dump. We have all seen it. Now, I actually have a plugin installed called Thread Dump Analyzer, another useful plugin for Visual VM that allows me to see what's going on inside. I just need to resize the window a bit. And sorry, guys, I cannot make the fonts any bigger in this tool, unfortunately. But we have 27 threads. I didn't want to... Sorry. Now I'm lost. I need to go here, look here. So the 27 threads, and how many of them? 6 are waiting on the monitor, right? Okay, let's take a look at them. Interesting. Anything suspicious? All of them are waiting on the monitor in the same line of code, right? Not surprising. We saw the behavior. So person store.java line 28. Remember, vector into the code. That's what we want. So let's go and look at that demo app. Let's look at the person store Java line 28. Let me just bring the window up a bit so you guys don't have to suffer the size. Hold on a second. I'll resize the window for you at the back. All right. So, first suspicion, and God knows how many times I have seen this in real-life applications. When I see something like this, cache by ID, and I see that somebody decided to write their own cache, my first message to them is, do not. Much like with cryptography, you typically don't want to roll your own caches because you will screw it up. So, but this cache is very simple, right? There's the person object that comes in, person object that we read. Here's line 28. Let's just make sure. Yep, that's line 28. Synchronized block, right? How do you fix it? Typically, you change this to some other more prescribed implementation. We ship a bunch of with the JDK. Or ideally, you go to a third-party cache. So let's try it. I know one. It's called concurrent hash map. Pretty useful, well implemented. Allows multiple readers, one writer, which seems to be the case here. We seem to be blocked on reading. So like any good cooking show, I do have a version of this pre-cooked, because otherwise we would take more time. So here's the version with a concurrent hash map, right? Pretty simple. I have a map, another map, and I took the synchronized blocks out. What should I do now? Because I actually see a couple other problems that I'm concerned about. Should we look at them now? Probably not, right? Remember, you want to go through the circle very quickly. Perform, tune, identify, measure, change, compile, measure again. So that's exactly what we're going to do. We're going to save this, going to rebuild this. And first I'm going to run it without any monitoring tools on it, because some monitoring tools can actually affect the runtime performance of what's being run, right? So I really want to measure this in real life environment. So I'm going to run it. It's going to warm up. So we started with 6.8, I think, or 6.18 seconds. Not bad. 2.8. One line of code. In the middle of the night, that's all I want to do. I want to wake up, I want to run some tools, I want to find the bottleneck, I want to fix it, compile, and go back to sleep, especially if I'm hungover the next morning, which never happens. Never. 2.853 seconds. Better, but not what we need. So let's again run through and look at things like dominating consumers again. So let's get the CPU history up. Let's run this. We'll finish for the warm-up to stabilize. Excellent. What do we see? Interesting. Have you noticed? Remember, we thought the dominating consumer was the operating system time, kernel time, right? Red is non-existent, and look, we managed to max out all 4 CPUs. That to me is an indication that I have effectively took one dominating consumer out. The next one is CPU, right? We're still bottlenecking on the CPU. It's a 4 CPU machine. I know the JVM can take advantage of all 4 CPUs, and it does. So we're going to look at this again. I'm going to start up the app. We're going to go to my favorite tool, JVisual VM, for free, right? The profiler, there's a bunch of people that will sell you a profiler for hundreds of thousands of dollars. We ship one with NetBeans for free. I'm just saying. All right, we can kill this. We know what's going on. Let's look at the threads. Let's run this. My goodness. It's all green. Green is good. It's working. Let's look at other statistics. Memory. GC activity. Oh, wow. Check this out. So one of the things that the app is measuring is CPU activity versus GC activity. Garbage collection, right? Garbage collection is awesome. When I started coding, I was coding in languages where you had to do it by yourself, for yourself. And boy, do I not miss those times. I have a couple friends that work on embedded devices. Some of them right now at Amazon Labs, Lab 126, whatever the name is, the guys that do the Kindles. They worked at Palm, they worked at other phone manufacturers. We, on occasion, will get drunk together, and they will argue with me about which language is superior, C, assembly, or Java. And on occasion, if we're too drunk, we'll go and write a benchmark. Java can be faster on memory allocation than C, because in Java, memory allocation on a heap is a pointer bump. In C, you have to start messing with things like malloc, memory fragmentation. But they don't trust me until we benchmark together, which we do on occasion. But here's what I see. I see GC activity of 22.5%. That's a lot. That's like a ton. What else is going on? And then eventually, by the way, check this out. The heap was kind of stable, and then eventually stuff went out of the heap. So it tells me that we're allocating something very rapidly, and we're probably not collecting it. The other way to look at this is to enable JVM's garbage collection log, right? So you do this like this. Actually, that's the wrong one. Right, here's the command line option. GC print details, GC print timestamps. And I actually personally found the person who, in the more recent versions of the JVM, made those timestamps not to be relative to the JVM startup time. Because I don't know why, but whoever designed the original version of hotspots decided that counting from the startup time is the best thing. Well, imagine yourself at 2 in the morning, maybe not drunk, maybe sober, on a JVM that was running for 15 or 60 days, and if you're lucky enough to have stable apps, trying to figure out 1,300 seconds divided by, when did this happen? right? So now there's a flag, and by the way, those little parameters used to be like black art. People would trade them under the table at the black market. After Oracle acquired Sun, actually, one thing that improved drastically is the hotspot documentation. The flags are well documented. You can Google for them. They're on the website. You don't have to take pictures. It's all available. It used to be literally, hey, do you know that flag? How much? All right, so how does this look? Now, GC logs can be interesting to read. I know first time I read one, I was like, what the hell is going on in here? It's like, whoo! It's like PC Young Gen, Perm Gen, 24 seconds, positional numbers. I had no clue. And again, it was before it was well documented, at least that I could find, and Google did exist. So I had to kind of go black market somebody and tell them, hey, can you show me how to do this? We'll return the favor. You don't have to. There's a lovely tool, a free tool that I use a lot, called GC Viewer, and it's not the only tool, but that's the one that I like. It's written in Java, you download it off the internet, that you can point your garbage collection logs. Here's one that we just generated. And by the way, like any other tool, probably nobody assumes that you're going to be tuning an app that runs for 2 minutes. So by default, the scale is larger, but we can change the scale a bit. We'll probably need to add more than 1 0. Yay! Awesome. More. One more. Okay. So you have a variety of things that it will visualize. Full garbage collection, incremental garbage collections, all the timelines. So we're just going to take some stuff out. Full GC lines, GC timelines, tenured young, used heap, and something like this, right? So this is my memory profile, right? In purple, if you see here, right? We have the tenured generation, the old gen. Caches eventually migrate there, long-lived objects migrate there, etc. Then I have young gen, and then I have the total heap. And there's a lot of stuff churning through there, especially if you add GC lines to this, right? There's some full GC going on. And you also get some details, right? Young gen, how many GC pauses happened, how much time has it run, what was the total number of seconds of garbage collection, right? Although it can be seconds, probably milliseconds, right? You get the statistics so you can start looking for it. We're going to drop out of the tool. You guys can learn it ourselves. We're going to, now that we believe that we have our dominating consumer is garbage collection, or memory allocation to be specific, we're actually going to go back to Visual VM, which embeds a portion of the NetBeans profiler. And we're going to try to do some memory debugging. All right. So we're going to go to a profiler tab. There's a memory profiler. There's a convenient settings tab here, and you can decide what to not profile for CPU. For memory, there's this awesome thing called record allocation stack traces. Right? Remember? Vector into the code. You want to vector into the code with any tool that you use. I want to know who does the allocations. The fact that we do the allocations, or if I know what class is being allocated, that tells me nothing. There may be thousands of places in the application that actually do this. So we're going to say profile object allocations only, record. For statistical purposes, maybe grab every hundreds, so we don't overwhelm the performance completely. Right? And we're ready to go. So we're going to hit memory. And we're going to let it run. The profiler will do its thing. Eventually the app will stop. The profiler will offer me to take a snapshot. More on that later. Here's a snapshot, right? So one other thing to show in a memory profiler that I did want to show is, give me a, oh, it's not live. We'll come back to that. Let's look at the snapshot, right? Something's going on here, right? There's lots of character arrays, strings, and string builders being allocated. Actually, 17% of all the, 64% of all bytes allocated were character arrays. The rest was string and string builders. 7.2 million allocations. That's a lot, especially since the rest is not. So let's see where. I know that string and string builders, I don't really care about character arrays, but I can simply right-click and say, hey, show me the allocation traces right here. Pretty easy. Actually, let's sort it back. I'm going to go for, actually, let's go for this. Let's do this. Right? You have all the allocations also organized by where they came. So most of them came from the copy and then from the abstract string builder init. And probably that's the one I'm going to go for. Vector into the code. Person store, get person again. Right? Probably time for us, in order to reduce the runtime of the application, we're going to look at this and see what's going on inside again. So again, we're going to go to the code. Remember, one performance problem at the time. I may have seen this performance problem in the past, but if my performance objective was 3 seconds, I'm a highly paid consultant. I billed my $500 an hour and I moved on. I have another customer waiting for me. So, get person. Most of the string concatenation happens here, right? Because that's what we use for the key, for the cache. Now, compiler is pretty smart enough, right? It's all compiled into a string builder underneath. We saw that on the snapshot, right? We know that it's actual string builder. There's no multiple strings allocated, but still, that's a lot. Any ideas on what we can do to solve this problem here? And I've seen this type of problem very common. A lot of people, it's very convenient, very easy to debug later on. A lot of people will use the string as the key cache. Any suggestions? Sorry? Use a what? All right, use a bin with 2 strings, or what we call it a surrogate or compound key. Yeah, it's like a hash, but it actually allows you to do a lot of things differently. And again, it so happens that I happen to have a version like that as well. Right? So here's what we did. We created this new class called person key. Right? And we'll look at it in a second. And we just basically initiate a person key, very simple class, very small class, as we will see later. So let me get rid of this. I'll show you how person key looks inside. 2 values, first name, last name, 1 constructor, hash code and equals. And by the way, looking at this hash code and equals, I can see that I can make it better. That's probably whatever IntelliJ generated for me. I don't care. I don't know that this is a bottleneck. I'm not going to spend my time on this. I'm just going to run it like this. If we find out that the hash code and equals I a problem, we'll get back to that. So let's do this. Let's save. Build. Shows you guys how old school I am. I'm building using Ant. I'm sure Baruch will give me a lecture on that later on. All right, run SH. We'll let this thing warm up. Okay, remember we started 6.18, I believe. We've gotten to 2.3, 2.4. We're trying to go for something like sub-second. Yay! Mr. Customer, here's my invoice. I'm gone. 590 milliseconds with 2 free tools, vector into the code, and this could have been a multi-million line of code system, right? Those are the type of tools, and those are the type of techniques we, in our production application, use day in, day out. And I'll talk about some of the new, more modern tools that will give you more information straight from your production environments. So tuning is much easier. So, second problem. We wrote this app, and we started up on production, and it runs, and it runs, and it runs, and it's everything handy-dandy. About a week or 2 into this, absolutely randomly, we get a call from a customer that says, hey guys, did you know that your thing was down yesterday? I'm like, no. Why? We have a watchdog, something fails, we restart it and we move on. Well, it didn't work for us, and we have a lot of unhappy users. We were running a training and we were using your product. That's one of the products I'm responsible for, a learning management system. And it didn't work when we needed it. Well, it so happened that you may have a Java memory leak. Never happens in real life applications, right? We all write code without leaks. So here I am at 2 a.m. in the morning again, looking at this like, whew, okay, what do I do with this now? Because that's the only information I have. There's no other runtime status on this JVM at all. So the first thing you want to do is probably use one of the very handy features that the JVM ships with. There's this lovely parameter. And you can say, hey, Mr. JVM, if you run out of memory, dump a heap. Yes, the customers will not be happy because the heaps take a while to write to disk, right? We're talking gigabytes and gigabytes of memory. On a large app in a highly contended environment with not enough I/O can take 2-3 minutes. But you know what? I would rather take 1, 2, or 3 minutes of writing the heap down to disk than trying to chase this thing blindly because I need my vector into the code. So we're going to run it like this, and we're going to get a heap dump. Now, there are a few other ways of running heap dumps. Obviously, you can initiate from the command line on a live running application. The problem with that, it pauses the app, right? And if you're running 16, 32, 64 gigs of RAM, that will take a while. Some of you can safely take the app out of the pool, right, if it's load balanced, and do that and then put it back. For others, I suggest knowing your operating system, because you can get a heap dump later on. The quickest thing to do on Unix typically is to get a core dump. Right? Tell the OS, hey, give me the state of this virtual machine as it stands in memory, just dump it into the file. That's much faster because it's raw memory written to disk. Right? And you maybe already, portion of it may be swapped, so you can do things like copy and write and map the pages together. And then you can post-process using one of the built-in JDK tools, and you can take that core dump that takes very little time to produce into a heap dump. What do you do next? You probably either run NetBeans or this particular tool. You can open heap dumps with it. But I also want to show you another tool that I use. Let me just find where it is. And the tool is called MAT. Memory Analyzer. It's an extension on top of Eclipse. The reason I like MAT is those heap dumps, you know, they're big. And it used to be that you needed to have as much memory on your desktop where you're trying to do any of this as much as you had in the heap or not more. And it also take a while to download them. And by the way, those of you that are working on production environment with sensitive information, PII, credit cards, encryption keys, they're all in the memory dump, so you have to be really, really careful moving those things around. So let's do this. Let's open a heap dump. No, that's the wrong conference. Kiev Java Day, performance tuning, demo app, build, classes I assume, demo app. Where's my heap dump? Where is mine? Did we drop a heap dump? No, we didn't. Aha. Failure by misoperating the application. Here we go. So now the JVM actually going to go and drop the heap. Excellent. Excellent. So should be somewhere here. Should be somewhere. Here we go. Now, the other beauty of this app is that it will do a lot of work. Oh, yeah, no, I know what the problem is. I did something stupid here, and I forgot that I was file permissions. Don't ask me why. I'm doing something that we tell a lot of people not to do. But somehow I managed to leave this in root. I was prepping something. So jprof, here we go. Now we should be good. Let's try it again. File. Yeah. So one of the benefits of this tool, it will not do all the work you need to analyze the heap dump every time you open it. It will pre-parse it. It will cache a lot of this information. And I don't have a lot of time left to show you a lot of those things, so I'll quickly try to find the problem. What's going on? Probably. Thank you. I will go stand in the corner later on. One last try. Otherwise, you'll have to trust me. I love it when live demo fails. It's only because Baruch is in the room. Yeah, he warned me that he will create trouble for me, and here it is.
At least it's proof you have a live demo.
That's true. It is a live demo. So the beauty of this tool is it parses the information, stores the indexes on disk, and then subsequent time when you're opening the 64 gigabyte heap, it will take minutes, it won't take hours, it will take seconds. You still need a reasonably powerful machine. This is a pretty small heap, and you can see it's kind of churning. This is a quad-core i7 2.9, I think, with 16 gigs of RAM, and it's still churning through this quite good. So I'm going to look into a vector into the code. Matt ships with a bunch of standard reports, right? And some of those standard reports will quickly allow you to zero in where the memory is. There's a bunch of things I won't have time to show. For example, with Matt, you can write queries against your object heap, OQL, right? Some of you may know there's this obscure feature in the JVM called string interning, right? It allows you to implement a flyweight pattern for your string. Basically, it means if you have an instance of Boolean, although Boolean implements it, or an instance of string, a particular string, you can make sure that you only have one instance on the heap, especially if you're reading a lot of metadata. Now, you have to be careful with it, with some of the JVMs, because those strings are stored on PermGen, and there's a talk on PermGen leaks and tuning later today. So see that, but you can implement this. We're not going to do this, but you can run a bunch of interesting reports out of the box. You can run queries. We were tuning our app, and we found that we have 1.2 million Boolean objects on the heap. That was strange, because how many Boolean objects should you have on your heap? 2. One true, one false. And if you're using proper factory methods that the JDK gives you, you will have only 2. If you don't, you will have several million. That's kind of embarrassing, by the way. So what you can do here is you can walk the heap. There are a bunch of reports. You can look at the histograms. I'll show some of the things quickly. So again, we know, look, we're running out of strings again. That's a dominating consumer. 23 megabytes of disk. You can do a couple useful things that we do a lot. You can walk the heap. You can walk the heap outgoing references, as if you were doing it in a debugger, right? You got an object reference and you can see all the references. But the beauty of this, because it does pre-processing, you can walk the heap in. So it will show you who has a reference to an object you're looking at. And that's what we're going to do. We're going to look at all the strings with incoming references, right? So I can start seeing what's going on, right? Threads. And eventually you'll get to something called GC root, right? Garbage collection route. And you don't have to do it like this. You can very quickly say, hey, give me all the shortest path to GC route. Lots of useful features. This can be a talk for several hours. There's a good documentation on this tool. If you need to do any kind of memory analysis, highly encourage you to play with this. You can really find interesting things. Now, in this particular app, I know the strings, and I know we're running out of memory, and I know they're not being cleaned up. And I don't know why. So I'd like to find out why. And I'm going to start looking. Actually, we're going to start from here, from the overview, right? Right here, it will tell me a leaks aspect report. And it will run it. It will analyze the heap. It will think for a second. And probably it's going to tell me they all sit in one class. Problem suspect number 1. Weak hash map entry. Weak hash map. I don't have time to show you how you find where the weak hash map live, but it's fairly easy to do. In this particular case, we will open the code and look at it. Because somebody did this. Somebody was browsing the JDK docs once and saw this. It's an awesome, awesome class. Seems like a great idea to implement a cache on it, right? Because, hey, listen, if the key is no longer present, the garbage collector will be allowed to collect the stuff, which means I can have the cache that never runs out, and it will drop some stuff. Sounds like a great idea, right? Well, this is a great idea if you know what you're doing. It's not if you're doing something like this. And I will get my monitor working. This one is for a prize. There will be a prize giving out here, a book on Java performance. To whoever can tell me why this weak hash that is implemented, you've seen the talk, you don't count, actually doesn't work. Yes?
Because value also reference. There is strong reference to value.
All right. Come see me after this. We'll figure out how to get you the book. Yes. So what the manual says is, whenever the key is not referenced, I will garbage collect it. Well, what we do is we took a person object, we took an object that it holds a reference to and put it as a key. When will it garbage collect it? Never. Now, it sounds funny now. It was not funny when we found one of those in somebody else's code, and we were like, hey guys, the app is crashing, running out of memory. Fortunately for us, again, we were looking for a quick solution in the middle of the night. It wasn't middle of the night, it was early morning. Like a true software engineer, I'm not a morning person. So my job was to fix it, compile, give it to CloudOps, and move on. Typo? I don't think so. Real man code in VI, man. Let's see. Now it's going to churn. Anyhow, the bug is not important. The importance is understanding your tools. The other thing I'll tell you guys, if you ever have any problems with getting any access to your production environment from your DevOps group, your IT group, boy, how you can be lucky if it's in a performance situation like that, because you're going to have a gentleman in a nice Armani suit standing right behind you, telling you that the customer is yelling at us, we need to fix something. This is your time. If you need tools on production, you need access that you never had before, this is when you get it. And get your tools and make sure they're pre-installed in the production environments as part of the standard package. I don't think this thing will ever finish, but at least it's not crashing anymore. So, to go back to the talk. The other type of tools we use in our environments is application APM tools. The two popular ones on the market that are not made by the company, but we make some other ones, is AppDynamics, New Relic. Those are the tools that run like a profiler on your real production environment and give you real-life information. And we actually have a person on the team who monitors the output of the tools. And the reason we like those tools is to give us that, again, magic vector into the code. This is a screenshot from one of our things, and we know exactly where we spent 9.5 seconds while performing that transaction. The tool is statistical, it aggregates data over time. We can start capturing this information, giving it to our development team so we can fix the performance problems before they become real problems. So if you haven't played with tools like that, again, I strongly encourage you, because systems are complex. The interactions between our components and the systems are also tough to predict, although I'm writing and talking the subject, so stay tuned for that. Use tools like that. Some additional reading. Kirk has a great blog on the subject. Attila, I will not butcher Attila's last name, gentleman from a performance tuning team from Twitter, has put together an awesome talk on JVM performance tuning, specifically about memory. We had an interesting surprise. We switched from 32 bits to 64 bits. Guess what happens when you do that? Your pointers become longer. Your pointers become longer, you use more memory, which means your gain of the heap just got lost if you didn't do it right. So look at his talk. He did it in InfoQ. There's a recording available. There's slides available. There's this awesome book called Java Performance by Charlie Hunt and Bina John. And I think with that, we're going to open it up to 5 minutes of questions. 5 minutes of questions. If you do have a questions, please raise your hand. We may have a mic here. Yes. Thank you.
What if problem is not in long execution of some small operation, but in spontaneous delays, like milliseconds, something like it? We are not sure if it's maybe preloading some classes, something like it. The first question is
so let me repeat it so everybody can hear it, because I don't know if everybody could. So what if the problem is spontaneous issues, like delays that show up? The best bet that we found is tools like this. Right? They constantly run on your production environment and they monitor the application, and that's how we find it. We have things like garbage collection pauses. We have things like, hey, Martin and I, when we were working on the domain tools, we had a firewall that was running out of memory, and on occasion sessions would get dropped and connections to the database all of a sudden will get dropped, and it would take a while for the tool to be covered. You have to monitor. You have to find the right tool that can monitor the JVM on the surrounding OS, and in my experience, it's the only way to track those down.
And second question is there any way to force JVM to precompile all the code? I mean, it's okay for us to have applications start in not 5 minutes, but an hour, but then don't have any pauses.
You mean JIT pauses?
Yep.
JIT generally doesn't pause because the compilation is done in the background. And by the way, JIT, and I'm not by no means an expert on JIT, JIT will recompile the code multiple times as well. So I would advise against doing that. I would let the VM worry about it, because JIT, if it's successful and smart, and again, don't take my word on it, I'm sure there may be a JVM expert in the house, JIT will change the way the compilation pass is done from time to time. So precompiling doesn't always buy you a lot of time. Any other questions? All right, there's one at the back. If you want to start setting up, you can probably unplug me.
Hi, tell me please, what do you think about high-level testing tools like JMeter, for instance?
They're awesome.
Never mind.
If you need to generate load, right? They're great because quite often, there is something to be said. We don't always test in the lab because we have a very complex system and replicating load in the lab is very difficult. So, and we have a stable system, and because we invest in ongoing tuning of the system, right, and monitoring it, we typically don't spend as much time in the lab. But if you're launching a new system and you need to find the bottlenecks, JMeter and tools like that to generate load effectively, because there are things like, if you really want real life stuff, I know the guys at Facebook replay production logs, the best thing ever, right? If you can replay production logs, you get the right environment, because typically performance problems come not just when you throw load at the system, but when you throw a particular pattern of the load, right? Things like JMeter will give you things like think time, click times, right? You can space things around, you can make it more real. So absolutely love them, and we use them for certain type of scenarios. One last question. Just say it, I'll repeat it. And
there is a flag for JVM, something like max GC time both millis or something like it.
You could.
Does make sense to set it to one? What's the pros and cons?
As a true professional consultant, my answer will be, it depends. It really does. In some cases, if you can afford it, yes. If you can make your JVMs disposable, because eventually you may not be able to collect enough memory, right, and you may not be in a steady state. If your JVMs can be disposable and you don't care about that, yes. So it's a very complex question, and GC tuning is a longer conversation that we have time here. So thank you very much for your time.